Let's do some examples using u-substitution. The first one we have is 9x plus 7 to the 9th times 7 dx. Now, the first step is to try not to. Now, you could do this without using u-substitution. I would not recommend it because it's just going to get really nasty really quickly. So instead, what we're going to do is we're going to try to use u-substitution. The first thing it says, choose something in parentheses or a denominator. Well, I could choose this or I could choose that. I'm going to pick this because it looks like it's the thing that's going to be the most complicated. So you typically pick like the most complicated thing you can. So I'm going to say u is 9x plus 7. So then the next thing I'm going to do is I'm going to find du. And I'm going to write that as du equals the derivative here, 9 dx. So I have 9 dx. Interesting. Okay, so with that, and then what I'm going to do is I'm going to change that into this. I'm going to say dx equals 1/9 du. So the reason I'm doing that is then I've got something here that's going to replace that, and then I've got something here that's going to replace that. So this becomes 1/9 du. This doesn't go anywhere, it's just a 7. And that becomes a u to the 9th. So my new integral is u to the 9th times 7/9 du. So at this point, I can pull the 7/9 out. And now I have something that's directly integrable. I can use the general power rule. I can say that 7/9 times 1/10 u to the 10th plus c. And then I can combine this. So that's going to be 7/90 u to the 10th plus c, which is 7/90. We have to go, so we did this number 5, now we have to do number 6. We have u's, we have to go back to x's. Whoops. So 7/90 9x plus 7 to the 10th plus c. And you can take the derivative to verify that. If you do, you're going to bring down the 10, so that's going to turn that into 7/9. That's going to subtract 1, that's a 9. By the chain rule, the derivative of the inside is another 9, which cancels. So that 10 and that 9 cancel the 90. What's left over is 7. And then, of course, the derivative of the constant is 0. So it looks like we've done this correctly. All right, let's keep going. So now I have x squared minus 9 to the 4th, 2x dx. So try not to. Again, we could multiply this thing out and do this by the general power rule. It's ugly, you shouldn't do it that way, but you could. So let's skip that for now. The next thing is to choose something in parentheses, or denominator as u. Well, I could choose 2x, but a lot of times I want to pick the most complicated thing. So let's pick that. Let's say that u is x squared minus 9. So then what we do is we find the derivative. We say du equals 2x dx. So I could do it this way, and that's perfectly fine too, but I want to show you a slightly alternate way since we're already doing it, which is that since I know what this is, I get that. So that's another way to do it. And then what goes here is u to the 4th. So now what I have is the integral of u to the 4th du, which is super clean because that becomes 1/5 u to the 5th plus an arbitrary constant. That's step 5. And then step 6, we get 1/5 x squared minus 9 to the 5th plus an arbitrary constant. And again, we could check that by the chain rule. We take the derivative, the 5 comes down and cancels, and then leaves us a 4 because we subtract 1 from the power. And then we take the derivative of the inside, which is a 2x. So that's that 4, 2x, and then arbitrary constant's derivative is 0. So we feel reasonably confident that we have done this correctly.